sorry, I had a computer issue here. So we have NaCl, MgS going into Na2S plus MgCl2. Alright, so what I was saying is this is a 1-to-1 ratio. If you included the charges, MgS like that, not charges, but those subscripts, it's saying the same thing. You only need one magnesium for every one sulfur. Having two is saying 2 magnesium per 2 sulfur is the same as saying 1 magnesium per 1 sulfur. And it's all about molar ratios, like I mentioned. Alright, here also what you need to do is one thing I forgot here is you need to balance it, right? So now there's 2 Na in the products, 2 Cl in the reactants, 2 Cl in the products. So that's basically it for ions and what they dissolve in. Another thing we could do is NaNO3 plus MgS. So basically what would happen here is you could have, you could have this. So remember, if we say this is B and this is A, this is C and this is D, we're going to have A, D, C, B, right? So that's from earlier. You're just kind of mixing them around. Notice that the NO3 could be NO3 is a polyatomic ion, is what I'm trying to say. So the NO3 kind of works as one unit. If you put that in some water, if you put this in some water, it's going to break up into this, right? It's going to break up into its ions. And we're going to have those floating around in solution. Oops. Now, you can see here, like I said, keep the molar ratios intact. So there's 1 magnesium per 2 for every 2 NO3s. So in this diagram, there's 2 magnesiums and there's 4 NO3 floating around. Of course, in real life, there's, millions and millions of them, but this is just a little schematic. So, but what happens when you work, we'll get into kind of some precipitation and some ions, still ions actually. So, we'll start with the most more general example we had here. So we'll go back to this. MgCl2 plus Na2S. Alright, so disregard this part for now. We're going to be talking about the reactants. So, this occurs in water, right? So, NaCl, remember, in water is going to break up into some pieces. Magnesium is going to break up into some pieces, and sulfide is going to break up into some pieces. And you're going to have a bunch of that floating around. So, this is what's actually happening. So you have this in solution, you have all this stuff floating around, right? And then when you react, you're going to have this stuff broken down, right? So this is reactants, and then products. But this is where it starts to get a little different. Now what we could have is some of these could be solid, some of these could be aqueous, or